Hi friends, again welcome to Jnana Learning. Continuing with the lecture on DSP. Today's topic is fast Fourier transform. So we have already discussed DFT, that is discrete Fourier transform, its properties and the methods of evaluating DFT and all. So fast Fourier transform or FFT is a highly efficient procedure for computing DFT of a finite series, and this FFT requires less number of computations compared to the direct evaluation of DFT or other methods of computing DFT. Now the FFT, it reduces the computation by taking the advantage of the fact that calculations of coefficients of DFT can be carried out iteratively. Okay, so that's why the computation procedure is less complicated in FFT. Now the FFT, it is based on decomposition and breaking the transform into smaller transforms and then combining them to get the total transform. So that is the method in which we are performing the fast Fourier transform. Now basically FFT, there are two classes of FFT algorithms, that are DIT FFT and DIF FFT. DIT means decimation in time and DIF means decimation in frequency. So these are the two classes of FFT. First one, that is DIT. So in DIT, actually the sequence for which we need the DFT is successfully divided into smaller sequences, and DFTs of these sequences are combined in a certain pattern to obtain the required DFT of the entire sequence. And in case of decimation in frequency FFT algorithm, the frequency samples of DFT are decomposed into smaller and smaller subsequences in a similar manner. So that is the basic difference between DIT and DIF. Now another parameter we have to know is a radix 2 FFT algorithm. What is mean by radix 2 FFT algorithm? So that particular term means the number of output points, or capital N, that can be expressed as a power of 2. That is, if capital N is equal to 2 raised to m, then m is a particular integer. So that is radix 2. So usually we say radix 2 DIT FFT algorithm and radix 2 DIF FFT algorithm. And similar way we have radix 4 FFT algorithms also. Okay, so that is the basic about the fast Fourier transform. So another parameter we have to know before moving to the FFT algorithm is a twiddle factor. So we know that the general expression for DFT of a particular sequence x of n is given by x of k is equal to summation n equal to 0 to capital N minus 1 x of n e raised to minus j 2 pi n into nk, 2 pi by n into nk, where k, the values of k is from 0, 1, etc. capital N minus 1. So this particular parameter, that is e raised to minus j 2 pi by capital N into nk. So here this particular parameter is notated as W of n, and which is known as the twiddle factor, that is W n is equal to e raised to minus j 2 pi by capital N. So again this expression can be written as x of k is equal to summation n is equal to 0 to n minus 1 x of n to W n power nk, where the values of k are from 0, 1 to capital N minus 1. So this particular factor is known as the twiddle factor. So while finding an 8-point DFT, the most common values for this particular factor are W8 raised to 0, W8 raised to 1, W8 raised to 2 and W8 raised to 3. That is 8 means it's for 8-point DFT. That is the value of capital N is 8. And the values for these parameters, that is W8 raised to 0, it is 1. Then W8 power 1, it is 0.707 minus 0.707J. And W8 raised to 2, it is minus J. And W8 raised to 3, it is minus 0.707 minus 0.707J. So these are the values we are using in the FFT algorithm structure. So we move on to Radix 2 DIT FFT algorithm. So here is the structure for calculating Radix 2 DIT FFT algorithm. And this particular structure, it is known as the butterfly structure. And in this we have to enter the values and we do perform the calculations and we get the final result over here. So in this structure we have 3 stages, that is the first stage, the second stage and the final stage. So in first stage, first we have to enter the values for which we have to find out the DFT, that is the particular sequence, values of the particular sequence. So this structure is for finding out the 8-point DFT. So we have 8 values in the input sequence. So we have to enter that particular 8 values in a bit reversal order, which means that here we have to enter the value for x of 0, x of 4, x of 2, then x of 6, again x of 1, x of 5, x of 3 and x of 7. That is the 8 values in the input sequence. Now here we have to enter the twiddle factor values, that is W8 raised to 0, here W8 raised to 0 or the first stage, again here W8 raised to 0, W8 raised to 2, here also W8 raised to 0 and W8 raised to 2. Again in the last stage W8 raised to 0, W8 raised to 1, W8 raised to 2 and W8 raised to 3. Also here are some values, minus 1 in the first stage, here also minus 1 in the second stage and here minus 1 in the last stage to multiply with the particular values. Now the computation is in such a manner that this diagonal crosses represents additions and the straight line represents the multiplication of particular values, which means that here we have to perform addition between this particular value with the value over here, and correspondingly we have to do the multiplications with the values seen in the straight lines. Thus we obtain values or result for the first stage over here. Again we have to perform the multiplications and additions for the second stage in similar way, that is diagonals, addition and straight lines for multiplications. Again we get the result for the second stage over here. Again in the third stage also multiplication and additions with the twiddle factors and the values over the straight lines, and finally we get answer at the third stage and the final result will be in the correct order, that is the DFT, the output sequence with x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6 and x of 7. So I will make it more clear by using an example in next lecture. So basically this is the way by which we are calculating Radix 2 DIT FFT. So this is the structure for calculating the fast Fourier transform, and this particular structure is known as a butterfly structure. So one thing we have to remind is that while entering the values to this structure, we use a bit reversal order for entering the input sequence and we get the output result in the correct order. So that's about the Radix 2 DIT FFT algorithm and its structure. So next is a Radix 2 DIF FFT algorithm. So here also we have a structure, that is a butterfly structure as shown here. So here in this case, that is in DIF algorithm, we have to enter the input sequence in the correct order. that is x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6 and x of 7. And at the output stage we get the result in a bit reversed order, that is x of 0, x of 4, x of 2, x of 6, x of 1, x of 5, x of 3 and x of 7. Then we have to write it in the correct order. Okay, so here also we have 3 stages, that is stage 1, stage 2 and stage 3. And here also we have to perform the additions as well as multiplications, that is in a way as shown in the structure, in the butterfly structure. Here also the twiddle factors are marked over here. Here we have w8 raised to 0, w8 raised to 1, w8 raised to 2 and w8 raised to 3. Also here we have w8 raised to 0, w8 raised to 2. Here also in the second stage w8 raised to 0 and w8 raised to 2. And in the final stage w8 raised to 0 in each portions. Okay, that is in the last stage. So here also first by doing the multiplications and additions we get value for the first stage. Then after that in the second stage we get the values over here, and in the final stage we get the values over here. So it is the DFT of the input sequence. Actually this is just a reverse of that of the DIT algorithm, that is the performing the addition and calculations. It is clear from the structure itself, and this will be more clear to you by using only an example that I will explain in the upcoming lecture. So this is just an introduction to what is a butterfly structure for performing the FFT, that is radix to DIT FFT and radix to DIF FFT. Actually this is for and calculating an 8-point DFT. Okay, so that's it. So thanks for watching the video. The DIT FFT algorithm and DIF FFT algorithm will be explained with example in the upcoming lecture. So for watching more videos, please subscribe our channel Jnana Learning. Thank you so much.